Today in science we're going to learn about the conservation of matter. We're going to compare the weight of an object to the sum of the weight of its parts before and after an interaction. We compare the weight of an object to the sum of the weight of its parts before and after an interaction. How does the weight of an object compare to the sum of the weight of its parts before and after an interaction? Let's review matter and learn what matter is. Matter can be solid, liquid, or gas. This time we will discuss mostly about what the solid is. Solid could be like ice, water, ice, any kind of solid object. Liquid like water, and then gas like steam. We'll watch a short little video, quick, that talks about matter.
Hey, what's matter? No, not what's the matter. Obviously, since you're here with me, you're pretty awesome at the moment. You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space. You already know about weight, right? That's just how heavy something is. Like if you've ever been to a doctor's office, the first thing they do is have you stand on the scale so they can measure how much you weigh. As for taking up space, another way of thinking about it is that all matter has volume. It simply fills the area it's in. When you pour water into a glass, for example, the water's volume is the amount of space that it takes up in the glass. So all matter has volume and weight, but it sure doesn't all look the same. Well, that's because matter comes in different forms, or states. Liquids are a state of matter that I'm sure you're familiar with. If you've ever poured yourself a drink while trying to watch TV, you might have noticed that liquids take up space, because once the space inside your glass is full, right on the carpet. Sorry, Mom. You also know that water has weight if you carry a water bottle. As you drink from it, it gets lighter because you're removing water from it. Solids are matter too, of course, probably the most obvious kind. Rocks are solid, and so is ice, which is just solid water. Soccer balls are solid, iPads, your pet Fluffy, and every single guy in One Direction. And just like rocks, all those things have weight and take up space. Now, you know what's weird? Sometimes matter can't be seen or felt, but it's there. Like the air we breathe. Air is an example of gas, the third main state of matter. And I probably know what you're thinking. How do we know air, or any gas really, is there if we can't see it? Well, we can prove it by doing an experiment. Science. Let's start by asking the question, is air matter? Because if it is, it should take up space and have weight, right? To see if air takes up space, look it, I can easily drop an empty balloon into this little box, but a full one won't fit. That's because the air that fills the space inside the balloon is bigger than the space inside the box. Now, does air have weight? Let's try something else. Take 2 empty balloons and tape them to the ends of a meter stick. Then we'll hang the meter stick on a string so that it's perfectly balanced. Now let's see what happens if we blow up just one of the balloons and put it back on our meter stick. Check it out. The end with the full balloon sinks. It weighs more than the empty balloon because the air gives it extra weight. The balloon full of air will always weigh more than the empty one because air is matter and matter has weight and takes up space, whether it's a liquid, a solid, or a gas. So listen, the next time someone tells you that something doesn't matter, you can tell them to their face that technically everything is matter. And tell them Sabrina said so.
So, that was one about matter. So we're going to look at the physical properties of matter. What are some of the things that you see? You need to write this in your notebook. You see things like with your eyes, you see colors, shapes, and sizes, how the length of something is, the width, and the height of something. With touch, you feel the texture, how smooth it is, how rough it is, how hard it is, how slimy it is, and you feel the temperature. It's cold, hot, warm. Here, you hear the volume, how loud something is, how soft something is. The sounds like sizzling, popping, hissing. Taste of the flavor of your foods. Is it sweet, salty, sour, bitter, spicy? Or if it doesn't taste that good at all. Smell. You smell odors. Is it fresh, sour, smoky, fragrant, or pungent? Pungent means real bad. And how do we weigh things? How are things weighed? Weight can help us compare mass. Weight can tell us how heavy something is. There are a variety of scales that measure weight. You have the balance scales. You have scales that tell you how much pounds. Scale that people stand on to get how much they weigh. A doctor's scale to tell you how much you weigh in the doctor's office. Lesson 2. You're still comparing the weight of an object to the sum of the weight of its parts before and after interaction. We're going to do a flip book. You're going to fold the paper in half. You're going to take a full sheet, hold it like this, and then you're going to fold it inward to the middle section of the paper. And then you're going to fold it down in the middle. And it should come out looking, if you cut the middle sections, it should come out looking like this. With little flaps. On the flaps, you're going to write mass, density, weight, and volume, which these are properties of matter. So write them down. I'll give you a few minutes. And on the inside, we're going to be writing the definitions of mass. How much stuff there is in an object. Write it down. Density. How tightly that stuff is packed together. Weight. How heavy the stuff is. How much gravity is pulling on it. And volume. How much space the object takes up. Then in the middle of the page, you're going to write mass. A bowling ball compared to a beach ball is relatively massive. A beach ball compared to a bowling ball is not very dense. That is density. Weight. A bowling ball on the moon has the same mass as a bowling ball on Earth, but approximately 1/6 of the weight. Volume. Each ball fills the hand.